Hey, thank you for signing up for the five-part supermarket workshop series. I'm so excited to have you here. And I'm really glad that you're taking the time to invest in yourself. And this is what it's all about. If you want to become better at commercial refrigeration and supermarket refrigeration, you have to spend time learning it. And this is what this five-part workshop is all about, is really to help you grow a little bit. I want to thank Mike Pod from Sporland for taking the time to chat about some great topics that we're going to get into over the next five workshops because this is really key. Mike's a third generation technician. He was in the field. He did it just like you're doing it now. And now he works for one of the largest component manufacturers in the world. He really understands those components that are in the supermarket or in commercial refrigeration. And that's why I thought he would be perfect to do this workshop with. The first workshop is going to be all about oil management. We're going to get into oil level controls, talk about the OL 60. We're going to be talking about oil filters. We'll get into high pressure systems, low pressure systems. We're going to get into what to look for when you start having oil issues in your system, which I'm super excited to talk to you about. We had some great conversation. We had some great questions during the workshops. And I hope this brings you some value. If you continue to invest in yourself, you're going to change. You're going to grow. Your mindset is going to change and you're going to want to do better. The more you learn, the more you want to invest in the things you do and the better it gets. I promise you, the better it gets, the more you learn, the more you do, the better it gets. I'm excited for you to check out this workshop. If you do have any questions and you want to learn more, reach out to me at info@refrigerationmentor.com. Head to the Refrigeration Mentor website. There's lots of content there. Head to the Refrigeration Mentor podcast. Tag me in any post you do on Instagram, Facebook, LinkedIn. I'd love to see that you're growing, getting better, learning more. This is what it's all about. Once again, thank you for signing up for this workshop. Now let's get a conversation going. Welcome everyone to this evening session with Sporland. My good friend Mike Pod here is hanging out with me tonight and all of you to really just share some knowledge with you. And we're going to talk about different topics on supermarket refrigeration. Tonight, we're going to get into oil management. We're going to be talking about components. We're going to be talking about troubleshooting, the hard stuff that's out there, the stuff that you can't see and you don't know what's going on with it. After this session, you're going to be able to see inside this oil system. You're going to be able to look and you can see through the pipe. That's what we're going to help you with. July 6th, next Wednesday, we're going to get in head pressure controls and strategy. 13th, we're going to get into TEVs, distributors. The 20th, we're going to get in defrost management. We're going to dive into that stuff, the other stuff that's really important to understand, really get into the root cause of an issue, because when you have multiple cases freezing up over time, multiple times, it's so important to understand what to do. And then the last week, we're going to be diving into EPR, CDS, CPR valves. It's going to be a great 5 weeks. I'm super excited about this. Mike, welcome to the Refrigeration Sportland Show. How you doing?
Well, thank you, Trevor. Thanks for inviting me, and thank you everyone for participating.
Yeah, Mike, why don't you introduce yourself to the audience and let them know a little bit about your background, what you do?
Will do. I'm a third generation refrigeration mechanic. My grandfather started in the industry basically at its inception in the 30s, and then my dad, I followed my dad into the trade. I apprenticed primarily doing supermarket work, installations, a lot of installations, and did some different types of service, did some chiller work and so forth. Since for about the past 18 years, so I was about 18 years on the tools, 17 years on the tools, and then for the past 18 years, I've been with Sporland. Started as territory manager, and I've been the regional manager for Canada for about the last 10 years. It's a brand I'm comfortable with. It's the only sales job I've ever had, probably because I'm comfortable with the product and the application. So glad to be here and talking about Sporland.
Yeah, no, I love it. And what I really like about it, I didn't know you were third generation. That's amazing to me because it's just a knowledge passed down year over year because refrigeration didn't change in the last 100 years. The process, the refrigeration cycle is the same.
Yeah.
Technology may have advanced a bit,
Yes, yeah, like getting into the parallel racks, and then the evolution of the parallel racks to the systems that we're seeing now. And yeah, that's where oil management kind of comes into play, as well as, but like you said, I've got a lot of my father's resources and my grandfather's old textbooks, and yes, superheat hasn't changed, subcooling, protecting the compressor, lubrication, and so forth. Those are all key attributes since the machines were built. Yeah, and it all goes back to the basics.
Yeah.
And that simple understanding of the basic refrigeration cycle, and really how we have to take that and apply it to a parallel system, multiplex rack system, and defrosting, and so forth. So that's why, I mean, my interest always kind of stuck to supermarkets, because I did centrifugal chiller work, I did some other things, but I found the refrigeration side of our trade the most interesting.
Yeah, me
And
too. Me too.
kept me in. Good.
For those of you that don't know about me and Refrigeration Mentor, my background is the same thing in supermarket refrigeration, starting construction, got into service, and then over the years just developed the skill and really the love for the challenge of supermarket work. But as I grew in over the years, and then I worked at a manufacturer, I worked at Emerson for many years working for Copeland. I really learned a lot from the manufacturer. Like that's really where I stepped up my refrigeration game, because at the end of the day, when you're supporting technicians in the field, you need to know how it all works and how it all comes together. And that's why it's important as a refrigeration professional out there, a technician, you need to know every component and every part and compartmentalize them into each section, like the oil management system. I look at this as a system is in itself. You know what I mean? It is a whole system that works with the full system. And I really, when I'm going in and troubleshooting oil issues or oil management systems, I do. There's a process that I take each time, and we'll talk about that throughout the session tonight. Mike, why don't we get in and we'll start off maybe talking about low pressure oil systems. Maybe we'll get into that first if you want.
Okay, well, I guess, um, yeah. So, but what I'll talk about first, I guess, is the floats, because they're kind of common across both the high and the low. Now they are. Back in the day, we had a high pressure float and a low pressure float, but for about the past 20 years, we've just kind of standardized to the OL60 float, which is the replacement for either an OL1 or an OL2 based float. They're physically identical in appearance, and then with the floats, internally, they're all the same. It's a makeup valve. It really, if a level drops below its set point, it will open a valve, allow the oil to feed through, and then close off when the level is achieved. The differences between the part numbers, which are basically, they're all in OL60, and I'm talking generically about Sporlan, of course, but they're all OL60s. The suffixes after that are really just the variations in connection configuration, or if it includes equalizer fittings, or if the inlet comes from the top or from the side. So if you can get a oil level to fit in your application, whether it's clearances to other compressors or clearances to the compressor itself, if the inlet comes from the top or the side or the back, the floats will work. So there's as far as replacement goes, they're all pretty much interchangeable. For about the past, I want to say maybe 10 years, we've had a universal flange. So that flange will mate to a 4-bolt Bitzer style compressor, or the standard industry standard Copeland style 3-bolt configuration.
So this is one adapter, or is there multiple adapters? Like,
so there's basically one flange style.
One flange
For now. There used to be, we had a 4-bolt flange and a 3-bolt flange. We've kind of standardized to this universal flange that will fit both the 3 and the 4-bolt configurations, but there are multiple adapters to accommodate the less common compressors that are used in the industry, because oil systems are on supermarket systems, but they're also on other parallel compressor systems that may use some Bach compressors or something unusual. So But what we've tried to do is standardize to what will mate to the common compressors in the supermarket field. That's where the volume is.
Yeah.
And two other things just with the floats, kind of before I move on. Well, we can talk about them as it comes up, and adjustment and so forth. But with the floats, there's typically a couple of different gaskets that come with them. For the gasket on the sight glass, because there's two recesses, the sight glass has a recess and the float has a recess, we use an O-ring and what we call a quad ring. So that fills up the space. If it's strictly the flange mating up against a compressor, that's where the O-ring would get used. So that's the kind of the differences or the applications and why we have the quad ring, the O-ring, and the other O-ring. So, the floats are common between the two systems. It's a simple makeup valve. We can get into some of the adjustments and so forth.
Yeah, because I do have that question a lot. Like I have many guys who are, or technicians, sorry, or
Yep.
professionals
Mhm.
that say, Trevor, I adjusted the oil 60, but nothing happens. I turn it 3 turns clockwise or counterclockwise, and I
Yeah.
don't see anything change. And a lot of people that I've talked to, they don't really understand how to set them up. I'd love to hear your explanation on how to properly set up an OL 60.
Okay. Well, out of the box, it should be set for basically your Copeland compressor, your standard compressor. It's that quarter sight glass, half sight glass range. So that's 3.5 turns down from the top, and that should get you in that zone. So what I like to do when I was commissioning systems, and is, okay, so this is a brand new rack or a newly installed oil float. With the new racks, I'd put enough oil after the evacuation and pumping the oil in. I put enough oil into the compressors so that I would see a level, not the proper level, not the full level, but I would see a level in the sight glass. And then I would pump oil through the oil line to to see that the oil went through the float, first of all, so there was no restriction on the oil feed. And then the level would go up, and then it should stop feeding when the float gets high enough to stop the flow. So there's your, that's kind of the best way. While you're installing, you're verifying that the float is going to stop at that predetermined level, because these are, you need, we'll talk about some upstream issues, because the oil has to get to the float in order to feed. And there's a couple of causes there. But also it can't compensate for a level that's too high. It can't dump oil out. There are equalization fittings that can help balance the oil, but it can't dump oil. There's no provision for that. But yeah, so Trevor's got up on the screen there the view of a couple of basically your standard OL 60, a couple of the deviations, and you can see the top inlet and the side inlet on the oil feed connection. Yeah. The quad ring and O-ring combination on the sight glass, and then the single O-ring either going to the adapters or to the compressor itself. So that's kind of it. So both arms are the same length. So either arm can be bolted to the compressor or have the sight glass on. Okay.
Yeah. So I have a question here is, can you damage these by adjusting them all the way out or all the way in? Is there,
Yes.
yes.
Yeah.
So can you explain that?
Yeah, because I mean, these are the float, the way that ours, these are hermetic. So they're assembled and then welded shut. So so basically turning it all the way counterclockwise. So it's 3.5 turns down or clockwise from the top. That's kind of our go-to set point. So the only adjustments really I would make is to raise the level and go counterclockwise to that counterclockwise to 3.5 turns or until you hit a stop. And don't use your biggest wrench to do that. I mean, that's got to be a relatively gentle adjustment there. You shouldn't be working against a lot of force. And then there's about 10 turns of total adjustment. But if you're down in that more than 5 turn range, you're kind of getting in the way too low for it to have any good value, unless you're dealing with some different, really unusual differential pressures. So for the standard stuff, I mean, out of the box, we're pretty good. You should be in an operating window for that float. And I will always, and I talked to some old technicians, I knew I was going to be talking to you. So anybody that I ran into, I said, what are your oiling issues? And it's basically undoing what guys have done, because the real problem may not be the float. It's a very, very simple device. It shouldn't, it's going to work or it's not. And a lot of the issues are system issues that are causing oil control problems.
Yeah, because I've seen this many times where a technician says, "Hey, Trevor, I went in, I replaced the oil pod, it didn't change anything."
Yeah.
And that's a consistent thing that I've heard. So let's get back to just the first thing, how to set it right off the first bat. So you pump down the compressor, you pump out all the refrigerant, so there's no safely, so you get it all out. So you get all the refrigerant out. You may have to dump some oil because if it's up there, so you might
it will run out if you. I mean, you've got to get it below the level of the flange of the sight glass. So then when you reattach, so using the gaskets and so forth, get it reattached. Now, if you pump a little oil into the crankcase so that the oil is now visible in the float, so you'll have to put some oil into the oil level control, right? The float mechanism. Then you will see oil in the sight glass. Okay.
So where would they put that in? Would they put it in the compressor oil pump? Would they put it
either
in the crankcase?
The compressor's not running yet, so you're putting it into the compressor, getting the oil level up. Now, you've replaced this so that if the rack's running, you've got this thing isolated, so it's not
safely.
Yes, yeah. Then once you see that level, so that okay, there's oil in the float, and then you can open up the oil feed line, and then it should only feed to half a sight glass. Like that's when because now the float mechanism is going to limit that. That's where it should be set for, that factory setting, 3.5 turns down. Based off of that, I would then make some adjustments, but I'd keep it, it's set at that level. It's a safe set point for operation, and in a way you can go.
And make sure, and just for everyone knows, make sure that you pull a vacuum on the compressor as well. Don't open the oil field line without pulling that evacuation and adding that. Just you gotta get all the air out of that system. So just throwing that point out there, Mike.
Yeah. Oh no, thank you. Because otherwise you're creating other issues down the road, right? Like so keep that system clean and dry, and non-condensables out of it.
So I've got a question for you on the gaskets. So you got a quad ring and you got an oil ring. Do you put PO compressor oil on those before you put on? Do you have to?
I like doing that. That's just my preference. Yeah, it's just helpful. They're compatible with refrigerants, so that's what they've got to be suitable for. Just getting the quad ring and the O ring in the right location so that we don't create any new problems. And then one of the comments that I was making, or one of the points I was making there, was on a newly commissioned system. I like to pump oil into the reservoir, but with the reservoir valve closed, so you're actually priming the oil system and seeing that it does raise up all the floats to the proper levels. And then so you've just proven before you're the guy commissioning this rack. I just verified all the floats work, the oiling system works, and then you can then pump oil in and have your level in your system. So then you haven't missed that, even on the evacuation side. You've proven that I didn't miss. Those ports were open and we got that cleaned up. So that's a point that I like to make there on the charging of the system. That's a good verification to make sure that that's all cool.
So I got a question for you. So now we're seeing a lot of retrofits because of regulations. We can't have 404 in racks anymore. You're going to 448, 449.
Yeah.
And I'm seeing a lot of retrofits from R22, mineral oil systems, low temp systems, to now 448, 449, different gas, different chemicals. And it's recommended to change all the gaskets, find all the solenoid valves, and we'll get into this in a few weeks as well.
Yeah.
But I see gaskets on this. Is it recommended to change those gaskets?
Yes. Yeah. I mean, there's the two, and they're on that page, the part numbers there, the quad ring and the O-ring.
Very important to do that.
Yeah. 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 Because that's one that could catch you out. And
We'll dive into that over when we talk about other components as well. But make sure if you're doing retrofits that you change these gaskets. Think about that. I got 7 compressors. I got to get the 7, 8 gaskets, or 16 gaskets. Sorry, depending on how many compressors you have.
Yeah,
Oh, great.
Yeah, because the refrigerants and the oils, they change the swell rates. So you make that conversion, and that O-ring is going to either shrink or expand. It'll take up a different form, and then you tighten it up again, and it's not necessarily going to be sealing appropriately. There's always cases where for some reason it's not a problem, but be safe and do it right.
Yeah, no.
Okay.
So exactly. So now we talked about the float. So this is the main component on the compressor that's feeding the heart of the system that needs lubrication. Everywhere needs lubrication, but that compressor needs the lubrication.
Yeah.
So what is after this, I guess? What is before this? So we have our equalizing line coming into this.
Well, some systems utilize the equalizing lines between the floats. So, and those equalizing lines, we've got 2 different heights. We have an equalizer that's at half a sight glass and one that's slightly above, and that depends on the oil level control part number. So those are one of those deviations that we have. We have some that are half a sight glass and some that are maybe a little bit higher. That would be, an FH or a TH or some of those suffixes.
Okay.
But not all of those are used. Often they're capped. It's not like a TX valve where you've got to use that equalizer connection. It can be, it's really, up to the rack manufacturer or even the compressor, because I've seen some equalization ports that are actually connected to the crankcases. I've seen that on some Carlisle compressors, and others where they do utilize the equalization ports on the floats. So that's really just to prevent overfeeding. If you've got an idle compressor and because of pressure equalization and other things, that oil level is dropped, and you've got a compressor that's running, that's getting a lot of oil carried back to it. Some of that oil can then be transferred, instead of the level increasing, it can be transferred to the dormant compressors. So yeah, that's kind of a benefit there. It's also something to watch when you're trying to pump down a specific compressor. Make sure you get that isolation done as well.
Yeah. So what are some of the things we talked about, the installing it, how to set it up and stuff? What are some of the things that could go wrong with these oil level controls? Yeah, and we know it's system related issues, but what are some of the things that can happen? I see a mesh screen in there.
That's the number one thing to take care of, is to check the cleanliness of that screen. We do have, when we get into the oiling systems, we've got oil filters that we want to see, but yeah, I've had floats returned for warranty, and the guys never even pulled the screen out. It was that, and that was the problem. So yeah, that is step one. If you're not feeding, would be to verify that there's not an accumulation of contaminants within the oil float.
Could you damage the float itself? Is there ways that you can bust or break that float inside? Have you ever seen that?
I've only seen them abused. I haven't seen them. It has to be kind of destructive to find out what the problem is, because really what you can do is drive it off the mechanism, which is too many turns in the opposite direction. We have had some instances where the snap ring will come off because it was adjusted incorrectly. The snap ring, there's a little circlip on the top of the adjustment assembly, and if that was, which right up at the top where the square fitting is, right in there, there's a circlip, and if that popped off, you can have some issues, and that's due to over adjustment as well. So they're a pretty robust. They're pretty, the problems are that we see are typically system related that lead to a lot of these failures. Now, it's not infallible. It's a welded device. It's got, the float's metal and mechanical. So there's always potential for things to be an issue. But overall, I want to say maybe misdiagnosis is probably the most common situation. But often, sometimes you got to do that to verify things because you
Yeah.
cannot find the issue. Swapping it out, you're 100% sure you've got something good on there. So
Yeah, and
yeah,
exactly. Sometimes you have to do that and
yeah,
to
just
do a check.
because you can't open it up and look at it.
Yep.
You've got to know. So that's on that side. So the floats are common between the high and the low pressure. Our mechanism is slightly different than some of our competition. Ours is a center ball float. Some of them are more of an arm, so forth, but we all function basically the same.
Mm-hmm.
So on the float mechanism, it's a makeup valve, and so forth. So to get into the two types of systems now, and there's primarily two types of oiling systems. There's a high pressure system and a low pressure system. And what determines that, and thank you for pulling these out. And these are images that are in our Sportland Bulletin 110-10, which is kind of our catalog on oil level controls. And it's also, this stuff's all online and all part of some Sportland YouTube presentations that are done by coworkers of mine, Jim Jansen and John Withouse. They've got a lot of YouTube videos. They've got
Great
one on
series.
high oil, one
Yeah,
on low oil,
check it out.
and
Chill
so
skills.
forth. So they dive into this as well. But so here's that oil system that we were. This is the low pressure system, and what makes it low pressure is the storage vessel is at low pressure. So in this particular system, what determines if it's a high pressure system or a low pressure system is the type of separator that you're using. So this Sportland does make oil separators. This particular type of oil separator would be just like an impingement screen float mechanism style of oil separator. So this is the kind of thing that would separate some oil. It accumulates in the separator. When it reaches the level of the float, the float will open and the high discharge pressure will push oil out of the separator and up into the oil reservoir. And
so let me pull that one up. I think that's down a few pages.
What's that? Well, it's right here. You can see the oil reservoir there.
Yeah. Okay.
And so in this one, it's got half a sight glass or half a vessel of oil in it. And so that's the feed. So you've just dumped high pressure oil into that vessel. And what happens now to drop that pressure, we've got that oil differential check valve, B. And what that does, be on the illustration, it's just a pressure. It's a one-way check valve that vents pressure to the suction, but it only vents it to a differential. So the pressure in the oil reservoir will be 5, 20, whatever the oil pressure, whatever check valve is selected by the manufacturer to be used. 20 is the pressure that I like, but yeah, 10, 5, 10, 20, and I believe we've got a 30 as well that are available. So that pressure will be 30 pounds above suction in that vessel. So you've got 30 pounds of pressure pushing onto the float, so that when those floats drop, there's enough differential pressure between the crankcase and the oil so that you get flow. Okay. So yeah, thank you, Trevor. There's your 20-pound differential pressure. That's what you should see. Okay.
Yeah.
So go ahead.
Yeah, and if it's in bar, it's like probably a 2.5 bar, or wait, 1.5 bar differential.
Right. Yeah. Okay. So issues that can come up here, basically. So now just leaving your system, you had 50 psi common suction header pressure with 3 compressors running. You just filled the oil reservoir. Now 2 compressors cycle off, and your suction pressure goes up to 70 psi. So now you're not going to feed any oil until you separate more oil and pressurize that oil reservoir again, and then vent the pressure off. And then now you're venting it off at now your oil reservoir will be up at 90 psi. because you're 20 psi above your. I mean, I embellished a little bit there. I'm sure your pressure wouldn't go up 20 pounds.
Yeah.
But that's how you can run into some oil feed issues during operation. Is you can see that reservoir pressure is actually the same or lower than your common suction for periods of system operation. So that's a check, and that's sometimes why you would want to bump up a lower differential setting so that you can it corresponds to make sure that you can get that feed. I've even seen 230 stacked up. I mean, that was for a real problem, but because they needed to make it through the night. Like they didn't want to run at a 30 psi, but they cycled so many compressors off during periods of low load that they would actually trip oil pressure switches. The compressors would cycle off, then the load would pick up in the morning. They'd build up the differential, they'd feed all the floats. So the tech would come in the morning, all the floats are high or proper, and all the compressors are off on oil failure. Not all, but enough.
Yeah.
So that's kind of a field issue where, okay, it's a pressure differential issue that's creating what could have been perceived as a float issue if that one float wasn't feeding or not feeding properly.
Yeah.
Okay, makes sense?
Yeah, no, it makes sense to me. Do you want to just explain, so when the compressors, just one more time, when the compressor starts to turn off and you start to lose more load and there's one compressor run, just run through that one more time.
Okay. All right. So like in this example, if you have all three compressors running and you've got a like you said, let's say 50 psi suction, or okay, then you cycle a compressor off, your suction pressure is going to go up. Okay, so if you separated oil at that 50 psi, you'd have 70 psi in your vessel. So it in your oil reservoir. So it vented that 20 psi. It tried to maintain that 20 psi difference over 50. So now when you're running now, you only have a 10 psi differential with that compressor cycled off. So it's still going to feed, but once it feeds, that you may consume all of the additional pressure in that vessel, and you're not going to feed again until the separator separates. And under your low load, you may not have enough mass flow to get maximum oil separator efficiency. So then you're not separating or accumulating as much oil in the separator to keep up with the consumption rate of that one running compressor. So you can run into some feed issues there.
I love it.
That's a challenge and I think I saw some comments there where guys have done that. They have addressed it with different check valves to address that issue appropriately. So that's good to hear, or good to see.
Yeah.
So that's kind of the drawback of that differential check valve variation.
So what's the best way to test that? So I got a 10 or a 15 or a 20 or a 30 or a 5 check valve there. What's the best way for somebody to check to see if that is functioning properly?
Well, first thing, check the pressure before you look at is a float feeding or not. You've got to check that differential pressure and see what it is. And okay, it's only whatever. I'm not feeding enough. So you can look at some look at the pressures during operation, maybe cycle some compressors or see something like that. But checking for that differential to see if it is what the value is on the check valve, and then either pressurizing the oil pressurizing the reservoir with discharge pressure, like just to put some pressure in there to see that it vents down properly to just above 20 psi. So you're then verifying that your differential check valve is good.
So for an example on this diagram, you'll have an isolation right here, right? Hopefully, like a lot of them do, maybe not. You can isolate it here and here, depending on your rack. There's a lot of different ones out there.
Yeah.
So you can take discharge pressure from this discharge. We'll say right here is the discharge. Put in, say, 100 psi in here.
Or just open it up to put some pressure in. Yes, but in the service valve at the top, you don't want to be blowing it in the bottom.
Yeah. Oh yeah. Yeah, up here. Yeah, if you're putting it down here, because you can check it from the bottom if you have an oil you know, an oil thing,
Oh,
but it
sure,
could be that too.
sure. It's just more for for dumping in some pressure because you just want it to vent out the check valve.
Yeah.
Like,
So
so,
you take in, you put 100 psi there,
yeah,
and then what you would do is you would open this valve right here. So this one here would open, and that should drop down to, if this is say 55 and it's a 20 in there, depending on,
yeah,
this should be now 75.
yep, yeah. And like one of the comments I just saw pop up on in the chat thing is you can feel that valve and it's hot, it's venting.
Yeah, that's a
But
good way.
but also, you know, sometimes it shouldn't, you know, and as long as it's venting and maintaining your differential, everything is good,
Yeah.
right? Because often, you know, if that can be a problem if it's over venting and not maintaining differential, it's just dumping all the time. But that's a good point.
Yeah.
Um,
Excellent.
and just one thing to add, and it was some of the technicians that I worked with back in the day, how they solved that separation issue where they had to stack the check valves up was they put, it was I believe it was a CPC system, and it had an additional temperature input they were able to use. So they actually put a temperature probe on the line from the oil separator to the reservoir. And then they could see that it did not feed oil because it never got hot for this period of time. So that was a way that they were able to use what they had there, log a condition, and prove what the root cause was.
Yeah.
So yeah, so that was,
And these are bulletproof valves. I see someone
yeah,
in the chat says I only changed one in 20 years. I know lots of people 20 years in the industry never changed one.
yeah,
You know,
yeah,
so they're pretty bulletproof, but a lot of people don't know about them.
yeah.
They, you know, they've been, I worked in 8 or 9 years before I really realized my first one, to be honest.
It's pretty simple. This is a pretty simple system working off just a pressure balance. Okay, and then I guess the next item there, just the oil filter, OF303, or ROF is a replaceable oil filter canister, basically, that you put a cartridge into. We do also have the SF283, which will fit in that location, and it was basically the predecessor to the OF303. OF303 has basically like 5 micron filtration. So it is the best place to clean up a system, or clean up oil is with, small particle removal, and getting down to that 3 small micron size is where you're going to really, clean the system up and protect your compressor. So our oil filters are all filter media. They are not filters and desiccants and other things. Desiccants belong in dryers. You don't move really, our opinion, you don't move enough mass flow through here to be effective in drying down a system. If you remove the moisture from the refrigerant, you're going to remove it from the oil, and you've got a higher circulation rate in your liquid line. So pull your moisture out in the liquid line, get maximum filtration in your oil line, and that will help you clean the system up. And on the oil filter side here, you'll notice that's an OF303. We also have a version with a bypass, and you'll see it kind of written in the diagram there for those that can see it. OF303 bypass. It's on the high pressure line in this drawing, or at least the wording is. The reason it's there is the bypass is enabled at a 30 psi differential pressure. So if you've got a low pressure oil system, you're never going, and you put the bypass version in, you're never going to activate the bypass. Okay, so that's you need to have it in a high pressure line where the potential for a 30-pound differential is possible, or it's not going to be activated. And these are a product of personal preference, because when you bypass, you're bypassing the filter element, and it should only bypass when it's obviously it will only bypass when it's blocked up. But so it's an option to put it in the line from the separator to the reservoir, if that was something you wanted to do. A situation where I can see using this is you've taken over a project and you've identified it as a dirty system. You need to get some cleaning done. You put one in there, it's gonna, it's basically gonna plug up. When it plugs up, you're gonna bypass, but then you're gonna filter it again. So you can use it in there as a temporary cleanup, and then you don't have to worry about it when it plugs. Like if you just use the OF303 out on the outlet of the separator, on the outlet of the reservoir, sorry, if that plugs up, you've stopped your oil flow. So the only oil flow that you're going to get is through the oil that's returned through the systems.
So if I got this straight, in say an older system, you're taking over a store, you have the OF303 in, but then you can add the OF303 BP in the high side of it and have both of them in there. Is that
that's an option? Yeah,
okay?
It's one of those things that you can consider.
Clean it up.
Now, the maximum differential pressure these can see is I think it's about 40 or 45 pounds. That's what the media can tolerate. Once you get above that, you'll start to compromise the media inside. So yeah, that would be I wouldn't do it as a permanent measure.
No. But
certainly as if that's a place that you're gonna, you want it to make it through the weekend, maybe something like that is a provision.
Yeah. So I get this question all the time. I've read lots of different manufacturers' manuals on these oil filters, and someone will say, okay, change it at 5 psi differential, change it at 10, change it at 15. Some even say change it at 20. And you have the bypass that says it'll bypass at 30. When it's in the low pressure side, the OF303, what do you recommend to replace it at?
I'm gonna say 10.
10. Okay.
I basically liked looking at it as what is it, clean? Because the problem is you're not always going to get flow. So for you to condemn this, you have to have 10 pounds of differential pressure while it's feeding, and you can't necessarily determine when it's feeding, right? So that's kind of it's hard to say, I guess it's more a maintenance swap out than it is put your gauges on and measure that differential.
Yeah. So for me, it's like 2 to 5. That's what I would be changing.
Well, that would be a differential pressure that you would want to, you'd want to see it. But if you put it in and you experienced, 2 pounds clean, I guess I'm thinking more suction filtery than I am oil line. But that's you can't just say, oh, I checked the differential pressure and there wasn't any, because it might not be feeding when you're checking the pressure. So you're just measuring pressures in a static system. So that's the trick there, where it's kind of more of a maintenance swap out, looking at the quality of the oil. I mean, if you've got dirty sight glasses, you've got dirty oil. Your filter's done. Like, unless you just put it in, you need to give it some circulation rate, and then you've got to clean the thing up. Suction filters. I mean, I like seeing the pleated elements in the header, because that's filtering the return, the oil, any oil that's coming back from the system before it gets in your crankcase. That's 20 micron filtration. That's equivalent to what the SF283 is doing. It's a 20 micron filter.
Yeah, because it's important. We need, as a refrigeration professional, keep our systems clean. It's so important. You have to keep them clean, and the people that mess up the system is us.
Yeah.
It's our install, it's our service, it's our maintenance that are causing the issues. So we really need to step up and do the job. Even if you're taking over an old store and it's a beat up store, try to do it right. Recommend the improvements that it needs, and explain why. When you're talking to the customer, explain why this is happening, and go and bring them and show them the oil, the sight glass, because oil is expensive now as well. Like a gallon of oil, people are telling me $100, $200 depending on the brand. And some of these systems will take a lot of gallons.
Oh yeah.
Okay, so that's great on the filter. Let's keep moving on. What's next?
Let's go to the high pressure system, so we at least get that one covered.
Let's do that.
Yeah.
So
and basically the difference, again, it's the type of separator. So on the low pressure system, you had a separator and a reservoir. So on the high pressure system, it's a combination. And the first variations of this that I saw were the Hussmann Turboshed separators. Yep. And basically they use impingement screens and centrifugal force and velocity change to, the oil falls out of solution with the refrigerant and collects at the bottom of the reservoir. So this reservoir is at discharge pressure. So it's still in the discharge line, essentially, collected at the bottom of the separator. So that's where the high pressure comes from. The oil is stored at a high pressure. And then, so in this case, the bypass version or the regular 303 would be used. And it goes into, and in this illustration, we're showing our generic Y1236C valve. If you're commissioning new Hussmann systems or servicing old Hussmann systems, it's a Y825C, and it actually looks a little bit different. Yeah. Instead of having it's kind of the power head. They're both based off TX valve bodies. The original valve, the Hussmann valve, was kind of patented and only sold to them. And this is a valve that we can that we can sell to any rack manufacturer and is kind of sold through wholesalers as a service part. So it's adaptable it's an exact field replacement. So form exact as far as function goes. You'll notice for those that are familiar with the 825, it's got a side connection as opposed to the connection on the top of the element. Yeah. But what these valves do, so instead of having that fixed setting on your reservoir, what this does, it maintains a fixed differential pressure between the outlet of the valve, so the oil feed lines that are leaving that regulator valve, and the header pressure. So out of the box, these are about, I want to say, a 17.
Yeah, I think that's what
pound differential. Yeah. Yeah. And yeah, 17 pounds. And that's in alignment with what Hussmann has on their valve. And then it's about a 2-pound adjustment change for every rotation on the adjustment stem, similar to TX valve. The Hussmann valve is a little bit more. I think you get about a 4-pound adjustment change with those. So what you do here is, instead of having that 20-pound differential check valve, you've got 20 pounds of differential, but it will fluctuate with the header pressure. So you've kind of addressed that issue that we had with that reservoir running out of pressure, where this is always going to be, it's going to be maintaining that differential, because the internal components are very similar to the expansion valve. They're basically balanced port expansion valve ports, but with a different type of operating mechanism.
Yeah, no, and I love that. So these would be realistically, I don't remember seeing them in the field a long time ago. It's been a long time since I've been in the field. I don't remember seeing these ones. I seen the black ones, like the 825s. I remember seeing those ones. Yeah. Yeah. When would you adjust these, and why? Because this, you wouldn't, it's just like a TX valve. Do not go and start adjusting this. Yeah. If there's an oil issue, do not go and adjust this. No different than the oil pots. Do not go and just start adjusting the oil pots. If it's been running for 2 years or a year or even 6 months, you would have noticed that issue already or something. Yeah. Don't go and just start adjusting this. So what is the process, either setting these up, or if you run into issues, the things to check?
Well, it's I guess, and I've seen a couple of the comments pop up. It's you can see circumstances where they kind of, you want to run a slightly lower differential pressure because they may find that they're blowing the floats open, or that they're overfeeding a little bit. So dropping that pressure, you're taking pressure off of the port. But I mean, I got to kind of stick by our standard recommendations. We kind of believe that's the right number to have, but you're the guy in the field making the call there. If you see that, we got to change this value a little bit to stabilize operation, maybe that's what needs to be done. So I think we've got some provision there for adjustment if it needs to be to accommodate. Also, with different compressor staging and operation, you might want to see different values there. But I never mess with them, and that's kind of my comment. But I'm not at the job site. Sometimes you've got to make a field decision on what you believe is the right solution for this.
Exactly. And on the inlet, I'm pretty sure right here there is a inlet screen.
Yep.
So if you're changing this oil filter or checking the pressure differential get high, clean that. Yeah. Let it clean it. You're taking it apart already. Clean that out. Yeah. And so I got a couple of questions here. The oil pot does not stop feeding, right? It'll just keep feeding if the pressure's too high.
That would be my yes. Yeah. You're blowing the now. you know, that I'd want you to verify what your differential pressure is, and a couple of other things as well, you know, to ensure. So what I would do, if your oil pump, if your oil float won't stop feeding, I would shut. Now, most of the oil controls have an isolation valve ahead of them. I would shut the isolation valve ahead of that, and then see what happens, because then your system should stabilize. Because make sure that you're not, that the oil level is a reaction to you're not adjusting the float based on oil that's returning through the suction line, because the oil float is only a makeup valve to compensate for the oil level dropping,
I love
not
that.
excess oil coming back through the suction header. So
Mm.
that's you want to dismiss that as a potential root cause. Things can get stuck in the floats. I mean, we do our best with screens and filters and other things, but we're you know.
But at the end of the day, that is not the component manufacturer's issue.
Yeah.
I've worked with component manufacturers. I work with Copeland and Emerson.
Yeah.
It's not that, not Sporla, not Danfoss, not Westermeyer. It's
Yeah.
us in the field or the manufacturer maybe of that equipment. You know, I don't know who's manufacturing your equipment, and there's a lot of good quality control here in North America and racks and stuff like that on the big manufacturers, but it still can happen. But from the component manufacturer side, there's huge quality control.
Yeah.
You know, there's
Well,
stuff that does happen, but you're not going to get a lot of dirt in there from the.
as far as dirt goes, yes, that's yeah, certainly we can control that. I guess the other thing is line sizing, and proper equipment sizing comes into play here, because you've got to maintain the correct velocities throughout the refrigeration system to keep the oil moving efficiently. Because if you you know, and that was kind of one of those stores that we had to bump up the differential, was because the system had such a big, you know, the night curtains went down and the doors closed and the lights went off and the load went away. And you know, the TX valves were just kind of pulsing a little bit, and the velocity went away. Then all the oil would wash back. And that's where you can have that uncontrolled situation where the oil is coming back through the suction lines. Well, you know, that's excess oil that got logged out there that then got carried back. So that's oil that's not being controlled. It's not being separated in the discharge, in the separator, and it's not being managed. That's the system. That's the result of the oil in circulation. So.
Yeah, my good friend from Keep Right Refrigeration named Peter Frame, and I think you know Peter.
I know Peter.
He I don't know why my cursor. I'm trying to draw a suction line here.
Okay.
But in the suction header here, there's something that he says is inside that manufacturers put in.
Yeah.
It's called quills, I believe. If you ever see inside of a header, right, like this, to reduce two things: liquid refrigerant if you're getting flood back to just rush that compressor.
Yeah.
As well as this little orifice here to get oil back.
To enable the oil return.
Yeah. You know, and so this is looking, if you cut this header right down here, and they're not all done, not all manufacturers do it like this, but this is one way that some manufacturers do. And that's what you're kind of talking about too. If this suction line has this much oil in it, like it's full of oil, and then you get all that oil back, it's not coming from this line, this oil feed line. It could be coming from this suction line.
Yeah.
Filling this up. So just be aware of that.
Yeah. Yeah. No, and that's, you know, that's that unregulated flow that, you know, where'd that oil, you know, somebody put that oil in there, and they may have to, that may be part of, to keep to keep sufficient oil in the compressors. You know, maybe there's a period of running cycle where that, you know, has to happen. So if you can address it and manage it, that's where corrections can happen. And, you know, often on renovations, you switch out, you know, 5-deck frozen foods, which I think are basically obsolete now.
Yeah.
It should be. We're so used up so much energy for not a lot of display. Converting, you know, if you reuse the lines, I mean, you weren't getting the oil back. Like if you switched to a glass door, you had to repipe the suction and or should be doing that. So
and this is also changing with newer refrigerants. Newer refrigerants have different mass flows, different velocities, depending on the size of the pipe. So a lot of them are close, but you need to go in as a refrigeration professional, go in and check this stuff. Go into line sizing software and look at it and just see for yourself. Do I have enough velocity? I'm doing this retrofit, just like you said. You pull out one of those. I did a post on it a few weeks ago, and I had lots of people on it. It's like when I first worked on one of those, I didn't know there was 3 sets of fans.
And yeah.
I was trying. I washed it out. I washed out that top drain perfectly. Well, I didn't know there was a bottom one frozen solid too.
Yeah, yeah. Well, they were, and they're heavy, hard to move,
Oh, I loved it.
pain
I
in the
loved it.
ass.
Yeah.
But anyway, and I guess the other point, looking at this image, the reason it's an issue with parallel systems or multiplex systems is that the compressor running isn't necessarily going to be the compressor running when the oil it pumped out gets returned. And you get different, different compressors are at different stages of life. And that's where some of this imbalance can come from. I mean, on a single evaporator, a convenience store system, one compressor, one evaporator, one condenser, whatever that compressor pumped out is going to come back to that compressor because it's a sealed system. In parallel systems, the oil management, you can't always depend on, you've got different compressors with different oil management efficiencies, I guess, as far as that goes.
I was at a friend of mine's manufacturer there last week, and on it, it's a single compressor, 6-cylinder, 6D compressor, and he had a oil separator, but did not have didn't have an OL 60 or an OMB or any oil thing. So it depends on the system. You just really got to understand. And because I never really, I did see it before, but I never thought about it until he showed me, and he's building all these equipment. And so actually he has a separator there and reservoir, and it just goes right into the compressor.
Back into the crankcase, but that's that one compressor, one system. And that's a management system in that particular case. They're trying to keep the oil from getting out into the evaporator. Yeah. So they're separating it, but putting it right back in. So that's a, kind of another way to approach it.
Yeah. So that's some great points. Here's a question. What's the best way to bring oil back that is stuck out in the system? Well, that's like some people are saying hot gas, get some hot gas. If you even have hot gas, because here in North America, in Canada, we use a lot of hot gas. In the US, is not as much. Europe, not as much. There's some parts of the world. So first step, if it's logging, you want to do an assessment. Where is that oil? Why is it there? Yeah. Before you start, you got to get the oil back, but you want to understand, is it the pipe size? Is it risers? Is it traps? You got to figure that out. Because the important part, you can get the oil back, or you can add 40 gallons of oil and then you get it running, and then 2 weeks later, another technician is back there. Yeah. You got to fix the real problem, whatever it is. It could be sloping towards the evaporators, not back to the compressors, the natural flow. Yeah. So piping is very important.
Yeah. So getting the velocity up in the lines, and that's system charge, and there's lots that can influence that. I've had examples, and it was mostly with brazed plate heat exchangers, where they've actually had to drain the oil out. Like the efficiency got so bad, and it was like, cut it, drain the oil out of the brazed plate, and get the efficiency back. And that was through one of my former coworkers, Garth Dennison. He was dealing with some people, and they took quite a bit of oil out of one of these brazed plates.
Yeah, no, I've seen that times too, where actually a journeyman went in and drilled a hole in an evaporator, didn't know what he was doing, and I was super surprised, and he just the bucket started filling up.
Oh, I've seen it during renovations, where you're renovating the store and you cut the lines out and the oil just won't stop coming out. Yeah, so there's systems out there that
so you gotta want to do your job right. Don't be taking soft copper, getting up into the rafters and just pulling it across. Don't do that. You gotta have proper slope. Back it. Another one here, Christopher says, low refrigerant level can cause oil to log out in the system. Not having defrost. That's another one, low temp systems. If you don't have a defrost, what happens when you're below 0 degrees Fahrenheit, minus 18 C, is that oil gets thick.
Mhm.
And, that could potentially be causing it to log. Maybe, maybe not, but these are the different things you want to check.
Yeah. But I mean, there are consequences to, different system designs. So there's one of the trade-offs with an electric defrost system. You're not going to have that high velocity circumstance to run it through. But
Yeah.
so and I'm glad the guys are bringing up those points, because those are all things that they've got to look at objectively when they're trying to solve these issues.
Yeah,
So
because at the end of the day, you're in the field. You got to make adjustment, and you got to do something about it as well. Like, but you got to think. You got to think before you just start adjusting stuff, changing stuff, cutting stuff. Think about what could it be, and I would really continue to go back to the sizing of stuff. Yes, it could have been engineered before, but what happened over the last 10 years? Was there an extra box added? Was there a lineup of cases that were changed? Did you add glass doors? There's all these different things that you'd want to look into to just find out. Ice formation on the bottom 1/3 or so walk-in evaporators can indicate oil saturation. The ice forms because refrigerant is saturated into the oil and it continues to boil off during the defrost cycle.
mhm.
Yeah. Plugged accumulators, yes.
Yep. No, that's valid. Yeah.
Yeah,
And
so
that's a dirty system, right?
yeah,
So
and that's what one of the big things is, and I've been on lots of energy audits, and I've seen lots and lots of case studies and stuff because adding. I talk about this in a lot of my supermarket courses I do. You can add a digital to the compressors. You can add drives to the condenser fans, the evaporator fan motors. You can add spray nozzles to the condensers. You can add VFDs or digital, if I didn't say that already. You can add all this fancy stuff. But on old stores, it's maintenance. Checking the super heat, setting that up properly, cleaning all the coils, cleaning all the drains, cleaning the condensers, make sure you have the right airflow. That's your highest efficiency. That is going to be your highest efficiency for that system. Is having a maintenance properly and running the way it's supposed to. And then you can add those other ones where you'll get the 10 to 12%, 13% efficiency. Because having a properly running, fully maintenance system, you're going to get the most efficiency out of it, especially on an older system.
yeah, I saw a question pop up there on the 283. I would install it without bypass. It is not a 30-pound differential. I can't recall what it is, because it's basically the 283 is a suction filter with 3/8 flare connections. So it's not. It was our first. If I look back in old sport and literature, we even used the first filters we used were 163 dryers. So 163 HHs were first, then we the SF, and then evolved to the OF303. So yeah, I don't know what the bypass setting is, but I don't think the device is as efficient. So I would only size those so they have no bypass, or install those so you're not using the bypass relief. And I will try and get an answer for next week on what that pressure is.
Yeah.
Okay. So
Quick question about your oil separator reservoir or the oil reservoir. You talked about it earlier. There's some of them that are have ball like a ball in them, a float in them.
yep.
Is that the reservoir, or is that the oil separator reservoir? I can't remember which one it is.
Well, Hussman has the little floats in them. I know
The
that.
Hussman?
I do not believe ours. I think ours are just a sight glass.
Okay.
It's been a while since I've been out on a job site
Yeah.
to call who's
And that's
on,
fair.
but they're just in it help. They help you visually see the oil level.
So things to check if you're running into oil issues. So if you go to a site and it's 2 o'clock in the morning and you're on call or whatever, and you're off on your Centronic, your Core Sense protection on the semi-hermetics, you're off on your Danfoss oil level control pen, whatever it is. Before you reset anything, do not be just resetting. This is the thing that had a bad habit when I was a young apprentice, where I would just go reset and see if it started up. Oh, it started up, it's good. You want to understand what caused that. There's no such thing as nuisance oil trips. I'm telling you right now, there's no such things as it. Something caused it. It may be a problem, but what was that caused that oil trip? So what you want to do is look into that oil pot. Is there oil in it or not? Take a look at that. If there's another sight glass on here, is there oil in the compressor itself? Just visualize that. Don't reset anything. Go check your separator. Do you see any oil in the separator? Do you have a process? and just have this process just for your oil management system, and have like a checklist to check all these things off before you start resetting stuff. Because yes, it might be off on a oil your demand because you're tripped on your Centronic or one of these controls, but have a checklist checking all these things before you do anything. Because in some compressors, you could have an oil screen, and that oil screen could be plugged for the pump. It has nothing to do with the OL60 or whatever oil management control you have on it. It has nothing to do with the separator. But most likely, if that's plugged up, if that oil screen in that compressor is plugged up, you're probably looking at all these other screens plugged and the filter probably plugged as well, like, or starting to plug. So when you're going to do this clean, check it all. Because if you go in, you just clean out this one compressor because you're on call and you don't do a follow-up call, well, then a month later, your buddy technician will be going out there and maybe now it's plugged at the OL60, or that oil filter dryer is plugged, or the Y12 336 is plugged. So just take the time to think about that. And maybe it's 2 o'clock in the morning, you don't want to do that. And I totally understand. I've been there. But you should write it down as a follow-up so someone comes out and checks that stuff. Because what's going to happen is 2 o'clock in the morning and someone else is on call and they got to go do it because you didn't really finish the real problem. The real problem, that whole oil management system is dirty and up. You just fix one symptom that you found because that oil failure control tripped off. Okay? So take pride in what you're doing and just think about it. Think about what could happen. I know this one's plugged. What about the other one? Should I check them? Should I come back and check them? Do I have, depending on your job as well. But it's important to check that stuff. Any other thoughts, Mike?
No, agreed. Yeah, you're spot on that. You certainly don't want to, you need to solve the problem, right? So you got
and usually a lot of times it's dirt in the system.
Yeah.
And there's lots of other things that it could be. We're just focusing on these few things. And I see some of them. What about the Trax oil system? So there's OMB, OMC. A lot of manufacturers make other ones. I know there's a couple European ones, but there are delays on these oil regulators leading to overfeeding. Well, it all depends really on those ones that kind of have a solenoid on them. So they're more kind of electronic. So when the oil level drops to a certain level, it says, okay, need to open that solenoid. The solenoid opens and injects liquid oil in there, or oil, and fills up to a certain level, and then it'll close that. And really, that's all it does. If you're overfeeding the valve, that solenoid sticking open, so it's a dirty system, or there's something maybe potentially wrong with that Trax oil, potentially. I don't know. How is it still getting power? They're pretty solid, but I've heard of issues with those as well, and OMBs and OMCs as well in the field. If you don't have the proper voltage, that could affect them. Could affect them the opening and closing. In your opinion, what do you feel is the most common misdiagnosis for oil system, Mike?
It's the floats, the level. Misdiagnosing the level control, adjusting it when it's not a regulation problem, when it's a return problem, and then ignoring filters or cleanliness.
Yeah. No, I love that. Another quick tip: if you go in and you're doing service, you need to check that equalizing line. So that oil equalizing line or the oil feed line to all those compressors, you want to check that. Is that warm? Is it cold? Is it hot? It's a telltale sign of some things. Have you ever seen that, Mike? You ever go in and your oil line's real cold?
Well, that's kind of an indication that you've got some refrigerant in there. I've seen also the too hot, where the differential check valve is just dumping, and dumping high pressure into your header, dirt as well. Adding to that, I guess the one comment a fella said, "How do I get oil back on a electric defrost system?" Well, basically it's identifying the system first of all, and then making sure that you've got the superheat and set up properly to keep your velocity up. Because if you don't have the superheat set right, you're not going to have good mass flow control, and that could kill your velocity down the suction line. it's going to be hard. I mean, I don't have an easy fix for that. You can't just dump pressure in there and blow it back. You know, as I would be tempted to do. I just want to talk about, I mean, maybe one other thing,
Yeah.
one other valve that is used on these high pressure oil systems, and it's actually an A7 valve. And I've only seen this in a few certain instances, but I have seen it, I've seen it. And what the A7 is, it's actually an automatic expansion valve. But what automatic expansion valves are outlet pressure regulators. So basically what you're setting is that outlet pressure that you're going to try and maintain. So if you know you're going to run a common suction at 50 PSI, you can set that outlet pressure regulator to maintain 70 PSI. So it's going to kind of act like your ORD, a differential valve, but it can work with the high pressure system. So it's taking high pressure liquid and just kind of maintaining a fixed outlet pressure. Whereas this Y1236 it will react to a variable. That differential pressure is what's going to try and maintain. So that's still out there as a control device that you may come across.
Yeah, I'll have to definitely look those ones up. I have not seen one of those before, but I always love learning new things, checking new things out.
Yeah.
Got a couple questions here in the chat again. Ever seen any type of filter downline of the OCV into the header of the discharge vapor can get dirty, and a lot of the time the line hits the manifold POST suction filter? I'm not sure. Understand that.
I wouldn't want to put any kind of device there because it could create a pressure drop. So you're not maintaining the right differential pressure.
Oh, I get you. Let me just pull that back up. That screen, I'll show.
Yeah, OCV, oil check valve, and if you're like
right here, so this is what they're talking about.
Yeah.
Putting
So I wouldn't
filter in
put
this line.
Yeah, you shouldn't really. I mean, you're venting vapor pressure there.
Yeah.
Okay, so.
Yeah, I wouldn't say to. I've never seen that before, so I wouldn't think that. I think this is where your oil's going through, flowing. That's just adding pressure to the, or reducing the pressure in here. So.
Yeah, and it's typically just I mean, it's onto the header, but it's a I wouldn't want to. Now I'm not sure if I understood the question in the sense of adding a filter in a different location. I mean, you're going to see you don't see a lot of mass flow through that differential check valve, right? It's venting pressure to the suction. So you're not gonna you might be filtering something, but you're not gonna
so I get the question. Yeah, Sam added more to it. So it's post the filter dryer. So this line here.
Yeah.
So down here, just say there's a filter here.
Okay.
So down here, I guess, past the filter, I'm assuming. So instead of going to the header, going past that filter to there.
Okay.
I think that's what you meant.
Okay, that would compensate for plugged filters. Yeah. So you would have, that would be the actual differential to the crankcase. But so I mean, it may be, I don't know what you're trying to fix there. I mean, that's where I would maybe look at a different differential check valve. But yeah, that's valid if you want to take the pressure drop through dirty filters into consideration to maintain a specific value, but depends on the application there, I think.
Yeah. Another question here. Tips to diagnosing a bad screen in a helical separator like a turboshoot. If the screen is damaged, the oil will still return through the system.
The oil, any oil in circulation is going to come back. How to diagnose it? Geez, it's efficiency. I've never had one of those apart myself, so I really, can't really comment too much on that.
Yeah, I seen them broke. One thing you need to, not only with that, one of the thing you need to understand is be checking these different pressures. Like, first off is understand the oil management system, because there's lots of different ones out there. Understand when it leaves the compressor, it goes to the separator here. Understand where all these pipes go, and you check every component that's in there. So you understand. See, we got in this oil management system, we have the separator, we have the reservoir, we have the oil differential check valve, we got service valves, they're included. We got an oil filter, then we got lines down to these oil pots. And this is that's the one cycle for the oil management. But we also have oil, like Mike said, coming back from this suction header, which is still, you got to consider that into the oil cycle, but it's not necessarily entrained in the oil management system. Understanding each one of those points and components and what they're doing and why they're doing, and the flow, where the flow is happening. I think that's so important. As a refrigeration professional, this is the things you should be doing. Walking around, analyzing, and making sure you understand that one section of the system. Because it only takes one component. It could be compressor 4 on this diagram that's running into the issues, but it's causing issues on 1 and 2. So just be aware of those things. Like Mike said, when some turns off and on and the load changes, you got to think outside the box sometimes. Think about what would happen if I do that. Okay, we'll answer a few more questions here. Can you clean your high pressure oil separator or reservoir? I guess it all depends the type of reservoir it is. If you can take it apart, like there's a lot of them that you can't open up.
Yeah, I've read older articles where on a turbo shed you could take the sight glasses off, like you have to remove it, take the sight glasses off and use a cleaning agent, like use a type of flush or something in there, but they can't really be disassembled. It's really just the float mechanism ones that you can for sure take apart.
Yeah.
But yeah, that's the only knowledge I have. Maybe some of the guys can comment on that that work on them more frequently.
Another one that I've seen, and this happened on CO2 systems, but it doesn't matter if it's this standard HFC system as well, or HFO blend, whatever it is that these separators are efficient at a certain temperature of oil. So now if you're running a really hot system, you got a high compression ratio and you're burning hot, that separator is not going to separate the oil the same way as it is when it's in its same position. And you talked about efficiency earlier, the percent efficiency of those separators. So if you're running too hot, that oil's super thin, it is not going to drop off. It's not going to drop down to the bottom here or whatnot and then make its way up. It's just going to be traveling through the system. So you want to be aware. That's something, if you come in and all of a sudden you have lots of compressors off on its oil failures, was it running super hot? These are just different things to check. I'm not saying this is it, but it's something that you want to look into. Good. Anything else to add, Mike? We're here.
I mean, hey, I think we pretty much touched on most of my my points.
Yeah. I think this was great. I think there's still some questions coming. We'll get answer some of those questions, put it in the show notes and stuff. And okay, let's grab just a couple more questions. What situation do you guys think the oil would need to be drained on a single compressor on a rack, and the pickup screen at the bottom of the crank needs to be pulled and cleaned? What situation? Well, anytime that compressor goes off on the oil failure control that we talked about earlier, you're going to want to check all those screens. Not just the one. On the Copeland ones, they're going to have a protector on the screen, and there's going to be a slit in it. That slit needs to be pointing down. When you pull all that out, you got to clean that. You got to clean, if it's on a OL60, you got to check that screen. You need to do all these checks. Hopefully that answers your question.
Yeah, because the oil filter is only filtering the oil that is coming out of the reservoir. Mm-hmm. All the oil returning from your cases or your systems is hopefully you've got some pleated elements in there in the suction line to catch anything that's coming back. But otherwise, that's the stuff that's coming back in your systems.
Yeah, and so when you are sizing stuff too, like as once again, as a refrigeration professional, you should understand what that separator should be sized for. If you see a compressor and you got 8 compressors, 5 compressors, and you got this little tiny separator, this little tiny thing, that can fill a pop bottle maybe, there could be an issue there. That might be too small. Or if you have a massive one, you have 2 compressors, but you have this massive oil separator, you should be thinking about, how do I size that? Does Borland have sizing software to check to see
Yeah.
if,
Not for, you see, we don't manufacture separators, so
okay.
we don't have any uh, tools.
Yeah, yeah, no, that's fair if you don't. But go check those ones go to the manufacturer of that equipment. Most of them have sizing software today. We're on the internet. We're in the 21st century. You can go look this up. So take the time to do that. It's hard work to do. It's hard. It's something hard that we're not used to doing. It's uncomfortable. But go out and figure that stuff out. That's going to make you a better professional in the field. Learning about these different things, these hard things. Um, Part of my quarterly maintenance is from the clients is to complete oil surface and clean it. What's your recommendation on replacing oil in a rack, Mike? What do you say?
Oh, geez, that's expensive now. It's, I guess I don't have we're not in the oil or refrigerant business.
Yeah.
So keeping your filters clean, and I mean, you should be able to clean your system up. I mean, we can't remove acids. I mean, sorry, you can remove acids and moisture through your dryers. You can filter the oil clean. There's options to improve the circulation. I mean, you can put bypass filter arrangements on. We've got a bulletin that shows how you can hook a filter up to bypass some oil and filter right out of a crankcase. But yeah, I don't have a standard recommendation.
Yeah, that's okay. For me, is you need to every year, at least, is to check the oil. Do an oil test.
Yeah.
Take the test
Yeah.
and see what it says, because this is something you cannot see.
Yeah.
And if it's got moisture in it, you need to clean that system up. And if you can't clean the system up, you need to replace the oil. And you're going to see this more and more in CO2 applications now. I see these professionals out there, they're doing the proper job now, where we cut a lot of corners. When I was in the field, I wasn't using nitrogen for the first few years, purging while I'm brazing. That wasn't really a thing that I was taught until it was starting to be spec'd. So do the job right, because these components that are plugging up, once again, are because of us.
Yeah.
It's something we did.
Yeah. So it's sight glasses, like the two things. The sight glass moisture indicator will tell you if you're wet. If you're wet, you've got to get it dry, because that will lead to oil breakdown. That moisture will react with your POE oil. That creates acids, and then the acids do some damage, and then yes, absolutely, you've got a situation. So if you can capture that beforehand. So acid tests are the only way to tell. The sight glass does not indicate acidity, it's moisture. So that you've got to do an acid test to make that determination. Pressure drop will determine solid contaminations. So solid contaminants. So pressure drop across your dryers or suction filters is solid contaminants only. You can have filter dryers completely saturated. They can't hold any more moisture or acid, but not have an appreciable pressure drop, because the moisture and acid get, I'll say, wicked in or pulled into the small angstroms and pores within the core itself. So you acid test, pay attention to your sight glasses, and pressure drop. Keep that stuff clean, and oil changes won't necessarily be necessary.
Yeah. And I totally agree with that. These are the things you need to check. You should be doing it if it has to be in a service. Your customer doesn't want to do maintenance, you got to plug that in at some point, because so many compressors fail because of improper installation. And it's acid that happens very easily in a system. And the big thing is, and the funny part is, if you got moisture in the system, it doesn't mean it's going to damage the system in 1 week, in 2 weeks, in 6 weeks. It could be 3 years down the road, because that day one installation. And it's really the compressor failing most of the time, but it happens because the day one installation, and it takes the compressor out 3 years later. I've seen this. I've inspected so many compressors. So once again, it goes back to us doing our jobs properly and making sure that if we're working on the oil system, why don't we check a few other ones? Make sure they're all clean in that time. It takes time to do it, but make sure they're all done so you're not there 2 weeks later on call at 2 o'clock in the morning or 3 o'clock in the morning having to fix it because you didn't clean all the screens. For an example, that first time. Awesome. Mike, I want to thank you so much
Oh, no
for
problem.
spending this evening with us. In another week, we're going to do another session. We're going to dive in and we're going to be talking about the head pressure controls. Love head pressure controls, strategies. This is really important here when you're in cold climates. Um, and we're going to dive into that stuff. If anybody has any questions throughout the week, you can shoot me an email, message us, and we can we'll try to dive into it and really help you. And what I want everyone that's still on here, what we've talked about here tonight, I want you to share some of this with somebody else. Thank you so much, Mike. Really appreciate it. I'll see everyone next week.
Look forward to next week. Thank you.
Awesome. Cheers.
Bye.
Hey, what did you think of that workshop? There were so many great tips and tricks. I hope you took some notes because I would love to hear what was your biggest takeaway from that workshop. Share it on social media. Head to Facebook, the Refrigeration Mentor page, and post it there. Instagram stories, Instagram posts, or LinkedIn posts, and tag me. And I would love to hear your biggest takeaways. I can't wait to see you at the next workshop.